We want to spend some time talking about the breadboard and how we're going to connect our electronic components to the board. As you recall, we have different pins from the GPIO that are on this GPIO extension board. Each of the pins are corresponding to a specific row, and we are going to use those pins to be able to connect electronic components directly to the GPIO through the GPIO extension board. One of the first pins that we will typically be utilizing is the 5-volt pin. So this is 5 volts that's provided directly from the Raspberry Pi, the GPIO. That's the physical location GPIO pin 2. And so we will be providing power to our electrical components through this 5-volt source. As we mentioned before, there are multiple grounds that can be found throughout the board. This allows us to be able to use a ground very close to the input or output GPIO pin that we're concerned about. All of the grounds are the same. They're all electrically connected together, so it doesn't really matter which one we use. Typically, you just go with the one with the most convenient spot. We're now going to take an electronic component and connect it to our breadboard so to make sure that we understand the proper way for connecting the breadboard. Please take out your dual color LED and follow along as we connect this to the breadboard. The first critical thing that we need to take into consideration is what is the electrical schematic, or what are the directions that the electrical current is going to flow through this particular component. So every electronic component that we connect to our Raspberry Pi, we're going to first take a look at the electrical schematic. This is really important to understand the symbols on there and understand what things are happening. This will also aid us in future diagnosis if we connect something and it doesn't fit as we intended it or doesn't work as we intended it to. The first item that we'll look at on the dual color LED is the connector. So this connector has 3 pins. Those pins are identified by circles in our wiring diagram. The pins are part of that white connector, and there will be wires that move out of the connector and from each corresponding pin. You can see that there are labels by each corresponding pin. Those labels match the electrical schematic for the dual color LED. The first label that we're concerned about is the R. So we can see an R on the dual color LED board, and then we see an R on the schematic. The next component on the board is labeled R1. This is a resistor. The value of this resistor is measured in ohms. It is a 220 ohm resistor. The purpose of the resistor in the circuit is for current limiting. The current limiting is in place in order to protect the LED. The next component is our LED. This is a specific LED known as a dual color LED. It can emit both red and green based on which terminal, either the R terminal or the G terminal, has power. Before we get into the uniqueness of this particular LED, let's take a look at how an LED works. Pause the video here and watch the video labeled "How does an LED work?" You can find the URL for the video in this lesson. Hopefully the video helped you to figure out how an LED works. The main points that we need to take away from this are that an LED has an anode and a cathode. The anode is on the positive side and the cathode is on the negative side. Current will only flow in one direction of an LED. The direction is from the anode through the cathode. When an LED is connected in this way, it is known as forward bias. This forward bias allows the semiconductor device to convert electrical energy into light energy, and we have the LED illuminate. When we reverse the polarity and put the positive on the ground side, this is known as reversed biased. A reversed biased LED does not illuminate. There's no current flowing through this circuit because the LED is preventing current from flowing in that direction. Because no current is flowing, we cannot emit light from the LED. We saw the ground pin used in the previous example, but I wanted to make sure to point that out. The ground pin is the third pin down, labeled GND. It's also labeled GND on the dual color LED schematic. An important part about the ground pin is both the R pin, which makes the LED turn red, and the G pin, which makes the LED turn green, are both connected to the same ground. For this particular exercise, we're not going to use the G pin or the R2 220 ohm resistor. That circuit would allow the LED to turn green, but we're simply using this board now just to be able to illuminate an LED. In future lessons, we'll learn how supplying power to the G pin will turn the LED green, and supplying power to the red pin will turn the LED red. One other important note is that in the schematic we're showing two separate LEDs. That's actually not the case. This dual color LED is one LED. The schematic separates them just to make it easier to understand. Let's connect our dual color LED to the breadboard. Something that's unique about my board compared to yours is I have taken out one of the wires, the middle wire that would go to the G pin. That's only to avoid confusion. If you want to leave the middle wire in, that's not a problem. We'll be working directly out of the red pin and the ground pin. The first thing I'm going to do is take my ground pin and I'm going to connect it directly to physical pin 20 that is a ground. Notice how I press it into the breadboard on the same row as physical pin 20. I'm going to take the yellow wire, which is connected to the R pin on my dual color LED, and I'm going to plug it in the row where the 5-volt power is. This happens to be pin number 2. I could also put it on pin number 4. We have illumination. So we are providing power or positive side to the R pin. It's going through the LED, current is flowing through the circuit and going to ground. Remember, this is called a forward biased condition, and it allows the LED to convert the energy into light. Let's take a look at what happens when we reverse the polarity for this LED. Let's take the black wire and connect it to the 5-volt source at pin number 2. And we will take the yellow wire, which is intended to be ground, and put it in physical pin number 20. As we would expect, we don't see any illumination at the LED. Remember that this LED is directional. It matters what direction the current is flowing. In this example, the current is going in the opposite direction, or the current is actually not flowing because the LED is blocking it. This is known as a reverse bias condition. The purpose of this video has been to help you understand how we're going to connect our electronic components to our Raspberry Pi. We have wires that will connect the electronic components to the breadboard, and then the GPIO extension board allows it to electrically be connected to the Raspberry Pi. Talk to your instructor if you're having trouble with this concept.